This lesson uses an animated applet to create a bouncing ball. The ball begins suspended in space and is pulled by gravity to the surface, where it bounces back up into space. Gravity then pulls it down again, and, well, you know how it goes. Things start getting repetitive. The Bounce 1 applet is the first attempt to get a bouncing ball. We have some calculations to do, and we want nice smooth motion, so the X and Y positions of the ball are kept as real numbers. They'll be converted to integers as a count of pixels when they're used to actually position things in the window. But working with them as doubles keeps the calculations more accurate. The diameter of the bouncing ball is 10 pixels. The thing that causes a ball to get faster as it's moving down and to get slower as it's moving up is gravity, and gravity is a constant. So we make up a constant and declare it here. Why this particular value, you may well ask? Well, I tried several values, and this one looked about right to me. I suggest that you experiment with this applet and try some other values in here. You'll find that all the values work, but the larger the gravity, the harder the fall. I just like the speed that this particular number produced. There is something new here. Notice that the values diameter and gravity are declared as final. That means they cannot be changed. Whenever you declare something as final, you must provide an initial value for it, and it becomes a constant that can't be changed by the program. Both diameter and gravity are named constants in this class. At any given moment in time, the ball has a specific velocity. The velocity value is positive if the ball is moving down and negative if it's moving up. That way, all we have to do is add the value of the velocity to the current vertical position of the ball to move the ball to its next position. It's quite simple, really. Now, the ball isn't going to be moving horizontally, so the value of x is set and it's left alone. Setting y to 0 starts the ball at the top of the window, and setting the velocity to 0 means it's not currently moving. As the animation starts running, gravity will increase the velocity downward, and the ball will move. In the update method, we test for the velocity being greater than 0. If that's true, it means the ball is moving down, so we test to see whether it's reached the bottom of the window. If it has, we bounce the ball. The velocity is switched to a negative number, and the position of the ball is adjusted slightly so it sits right exactly at the bottom. The velocity is then adjusted by the gravity. Gravity is always positive, so it always pulls down. If the velocity is negative, this action reduces its size, which slows the ball as it's going up. If the velocity is positive, gravity increases the velocity, bringing the ball down faster. The position of the ball is then adjusted by the magnitude of the velocity. The paint method does the same job it always does with a ball. It fills the background with solid color and then draws the ball at the current location. Notice the casting of the arguments to the call of fill oval. The method requires integer values for x and y, and we're using doubles, so that makes it necessary to cast them to the right type so the method will accept them. Here's how this applet runs. Notice how the ball gets faster and faster as it moves down, and it gets slower as it moves back up. Now, I know the motion is a little jerky here, but if you run this applet yourself, you'll see that it's actually quite smooth. But there's something that isn't quite right. It's always going back to the same starting place. It bounces all the way back up every time. That's not natural. Let's fix that. This is another version of the same program, but we've added friction. This statement right here introduces the inefficiency we need for reality. Each time the ball hits the bottom, it loses 5% of its velocity. This means it doesn't bounce as high as it did the time before. Let me show you. Now, let me suggest that you experiment with this applet a bit. Change some of the values and see what happens. This applet contains a number of the most fundamental things you'll need for animation. We've got a couple of more animated applets coming up, and you'll need to understand this one before you can understand them.